Again, welcome to the Purkeys Multimeter Basics, yearly refresher course for technicians. Not to be boastful, but I think this is a good refresher class for, technicians that have been in the field for long, but it's also great for new hires, just to brush up that, every one of the Purkeys products deals with electrical in some way. And if you can't use a multimeter, it makes it very hard to diagnose or troubleshooting these systems. So we do try to give back and support the industry with all these. So today we're going to talk about multimeters. When we say multimeter, it's a meter that does multiple different things. Some people are very proficient at all the different functions. I visit shops and you'll see you see a meter that's 5 years old and still looks new. That's usually a pretty good indicator someone doesn't use their meter. Or see people that only use one or two functions. They have no idea what all these other, symbols and everything else mean on it. So, but we say a multimeter, it's a voltmeter, it's an ammeter, ohmmeter, diode check, continuity check. Depending upon meter two, it may have frequency, percentage, just all kinds of different things that meter can tell you. And if you don't know how to use them or don't understand what that meter is telling you, obviously you're going to be at a disadvantage. And this is, kind of our multimeter 102, where we do go more into the frequency, pulse width modulation, min-max function, hold, relative function. So in a lot of these work with those other features or functions, it just gives you even more diagnostic ability. And pretty much every service manual anymore, assumes you know how to do all these things. But whether you're using the shop meter, your personal meter, or you're borrowing meters from somebody, the other thing too is if any technicians get involved in tech events, before you use a meter, there's things you always want to do to make sure that meter is ready to use. And one thing that you're showing a particular brand of meter here, but if you turn it on and you get a little battery indicator comes on, or some meters will actually say BATT across the screen, what that's telling you is that internal battery is low, and you run the risk of not getting accurate readings because of it. So if you do get the little battery symbol, and this one kind of looks like a AA battery, some of them look like a little car battery symbol, or again, some actually spell it out. But if you do have a low battery before you use this meter, you got to change that battery out. One thing is you get what you pay for. And when you buy anything that comes with batteries, do they ever put the best batteries in there? Answer is no. But if you're going to replace your meter battery, some of them run on AA, some of them run on 9 volts, but make sure you use a good battery. You don't want to ruin a good, high-dollar piece of equipment because you bought a generic, no-name economy battery, and 3 months later it leaks acid and ruins your meter. So make sure you do buy a good battery. One thing I always tell people, about batteries, what are you supposed to do with your smoke alarm once a year? Check the battery or change the battery. That's cheap insurance. Make sure that thing's always ready to be used. The other thing we're going to do is we're going to check the leads. Now, if you set your meter at ohms, when ohms is a little upside down horseshoe symbol, a Greek letter omega, set it on that, touch your two leads together, it should zero out. It's telling you either got something wrong with the meter or you got something wrong with the leads. We can go by and test all those step by step. So first thing you can do is take both your meter leads out. You just grab you a paper clip or a short piece of wire and jumper across those two ports there. And you should get a zero reading, or very, very close to zero. Most meters, your 0.1 is going to be in the range of being correct. But if you get very far off, that's going to impact all your readings on any resistance check you do. So you got to make sure that those leads are right. If it doesn't zero out doing this, it tells you, hey, it's not a lead problem, it's a meter problem. That's one of those things, again, you get what you pay for. Buy a good meter, something that has a calibration program, so that if it does get out of calibration, you can send it in and get it calibrated to make sure it's good working order. If it did zero out, we're going to check our leads. Doesn't matter which one you do first, but first we're going to do the red one. We're going to put the one end back in the meter like it belongs, and we're going to take the tip of the lead and put it where the black lead would go, and we're going to check it. If it zeroes out, it says, hey, your red lead's good. We can do the exact same thing with the black lead. All we're trying to do is isolate it. Do I have a meter problem? Do I have a lead problem? What is it? What do I need to address? The other thing, you want to make sure you're familiar with the meter. Again, different tech events, you may go to a station, you have to use a meter you've never operated before. If you do a tech event, I always strongly recommend you bring your own meter, the one you're familiar with. But most meters anymore are auto ranging or auto voltage. What that means is whatever you put it on, whether you put it across a battery, in a truck, or you put it across a AA battery, or you stick it across a 48-volt system, whatever, it's going to move the decimal point to give you the best reading it possibly can. That if you're on a small scale, it's going to put it down to a 2-volt scale or a 20-volt scale. The meter's smarter than all of us put together, so let the auto range function work like it's supposed to. The one thing you want to make sure of is on this particular meter is up in the left-hand corner, it gives you a little auto. It says you're in automatic range. Some meters are opposite. Instead of saying auto, it'll say MAN or manual. That's if you think you're smarter than this meter, you can toggle through. Again, just like we talked before, a 2-volt scale, 20-volt scale, 200-volt scale. And there are times that is handy. We've noticed that, again, depending upon the meter, some of when you get into a very low voltage, say less than 2 volts, the meter has a hard time locking in on those voltages. So if you manually put it on 2 volts, it will give you a quicker response and play the voltage back. One thing you always got to be very careful about, though, is say you're checking an outlet in your house. Put it on AC and you accidentally put it on a 20-volt scale. You go over there and stick the probes in the wall outlet. What's your meter going to read? Answer is, oh well. Does that mean there's nothing there? No. You told the meter the highest you're going to see is 20 volts, and it's obviously going to be above that. So you got to be very careful. If you assume there's nothing there and start taking that outlet out, you'll find out real quick the hard way that no, there is still power there, just on the wrong setting for it. Again, the range button is going to toggle between manual and auto. Just, again, make sure you're on the right one. If you're not sure and there's a meter you're not familiar with, make sure you toggle through. The easiest thing to do, too, is turn the meter off, turn it back on. 99% of the time, it will automatically default to the auto range function. And the other thing, too, is you got to make sure what your meter is capable of reading. These particular meters we're showing here will read up to 1,000 volts, whether AC or DC. If you should try to read something over 1,000 volts, again, it's going to read that OL. You're out of limits, out of luck, whatever you want to call it, that you're above the capacity of that. So it doesn't mean there's nothing there if you get an OL. You're just beyond the capacity of that meter. And I've said it before, and I'll say it again, that you get what you pay for. You buy an inexpensive meter, it may only go to 200 volts or 300 volts, depending upon the meter, and it can very much limit you what you can or can check. So, again, make sure you're familiar with the meter you're using. Same thing on voltage or DC voltage. It's going to give you an icon, say AC or DC, or it'll give you little symbols, and just make sure you understand what those are. If you have it on DC and you stick in a wall outlet, it's not going to hurt the meter. Will it display something? Yes, because it's trying to make some sense of a voltage it's reading. Obviously, it's not going to be anywhere near correct. So just make sure you are on the right function. Now, we've talked a little bit about getting the meter ready. We're actually going to use this meter. And the first function we're going to talk about is using it as a voltmeter. One thing about voltmeters, people think they're a lot more high-tech than they actually are. A voltmeter is actually really kind of dumb. That when you take your meter and you put it across a battery, you put your red lead on positive and you put your black lead on negative. What does the red lead read? Obviously, I can't hear y'all out there, but battery's at 12.5, so my red lead is going to read 12.5. What is my black lead going to read? Zero potential or negative at the negative post, so it sees 0. What is the difference between those 2 points? That's the only thing a voltmeter tells us, is the difference from 2 different points that the leads are on. So 12.5 minus 0 is 12.5. I take that same battery, I'm going to grab a couple of cables and hook it up to a starter, just like it is on a big truck. With no current flowing, I can move this meter anywhere I want to in this circuit. Guess what I'm still going to read? I got my red lead on starter positive, I'm still going to read 12.5. I've got my black lead on starter negative, still going to read 0 because nothing's happening, 0 potential there, so still displays 12.5. Take my red lead starter or battery positive, black lead at starter negative. Again, same thing. I can move these wires anywhere I want to in this circuit. As long as no current's flowing, still going to read the same thing. Now, one thing is people always want to use a voltmeter, red on positive, black on negative. Can I use a voltmeter positive to positive? And the answer is yes, I can. But if you look at the example right now, I've got my red lead on battery positive. I have my black lead on starter positive. What do I read at the battery? 12.5. What do I read at the starter? 12.5. What is the difference? Answer is 0. The key to this right now is no current is flowing. If I don't have current flowing, I can't have voltage drop. If I can do it on positive, can I do it on the ground side? Answer is yes. Oops, I'm going to back up. I got a question for you right quick. Hopefully you didn't see that slide. But if I had my meter connected just the way it is right now, and it displayed 12.5, what would that immediately tell me is wrong with this circuit? Just think about it for a minute, that if I'm reading 12.5 at the battery, which I'd have to because I'm connected directly to the battery, and I got my black lead at starter positive, in order for the meter to display 12.5, what would that have to tell me is wrong with the circuit? Answer is the cable's open. It's got a break in it, whatever. Now, even if one single strand was still there, this would not happen, so it would have to be a complete break. Now, it could be a circuit breaker's tripped, fuses blown, something, but there is a complete open in that circuit. Generally, that's never going to happen on a starter because of the size of the cable, but the same rules apply for any type of circuit you're trying to troubleshoot. You'll see people a lot of times at, again, at a tech event or whatever, will see that and their first reaction is 12.5. Ooh, that's a good reading. No, that should immediately tell you what the problem is. But just like we can do this on the positive, we can do the same thing on the ground side. I got 0 at the battery negative, I got 0 at starter negative. Nothing from nothing leaves nothing. But one last time, is no current flow. Can't have voltage drop with no current flow. Well, now we're actually going to put this under load. And for simplicity, we're going to show 2 different meters. I got 1 meter across the battery. I got a different meter across the starter. Now we're actually cranking that engine. If you look at the 1 meter going across the battery, I got red lead on positive. It's reading 8.5. My black lead is reading 0. Difference is 8.5. I take my second meter. It's going across the starter. What do I read at the red lead? 7 volts. What do I read at the black lead? Negative 0.3. What is the difference there? 6.7. So how much voltage drop do I have in this entire circuit? If you subtract the 6.7 from 8.5, that tells you there is a 1.8 volt drop in this entire circuit. Now, where is my voltage drop? If you sit there and study this long enough, you can figure it out, but you can very easily do it taking your meter and go step by step. I can take a meter and go from positive to positive, just like we did before, but now we have that current flowing. I had 8.5 at the starter positive. I had 7.0 at the black lead at the starter positive. Difference is 1.5. Now, if we had a 1.8 volt drop total, and we just checked the positive and I had a 1.5 on it, what does that tell me I have to have on the ground side? Answer is 0.3 volts. So if I was going to work on this truck, which side would I start on? Positive or negative? Pretty clear answer that you got 5 times as much voltage drop on the positive side as you do the ground side. So I would start with the positive. what's the first thing I would do? Take it apart, clean it, make sure everything's getting a good connection, put it back together, tighten it, retest it. Now, when we talk about, this scenario right here, I'm not sure how many of you out there run any of the test equipment that does a voltage drop check, but that's exactly what we just did that the automated equipment does, is it puts a load across the starter to simulate a crank, looks at the voltage across the battery, looks at the voltage across the starter, does all the calculations, tell you if you're in spec or not. Now, TMC spec on this test would be you're allowed half a volt at 500 amps. Would this truck be, good or bad? Well, the answer is you don't know. And why don't we know? Because we have no idea how many amps that starter's pulling. So to do it this way is not a fair test. That's why the automated equipment's out there, so it puts a load on it to simulate it and knows what that load is and does all the calculations, tell you pass or fail. But that's exactly what that tester's doing when it does the test. And we're talking about cranking cables right now, but just like our previous examples, the same rules apply for any type of troubleshooting. This could be, a harness going over to a blower motor. It could be going to the AC compressor, for the clutch. It doesn't matter what the device is, the rules still apply. You still have to test under load, and your voltmeter can tell you what that drop is between those 2 points. But in order to do it, you have to have load, and you have to know what that load is. So, kind of a summary of our voltmeter and voltage drop is the voltmeter only tells us the difference between 2 different points. In order to have voltage drop, we have to have a load, and we have to know what that load is to properly test it. Next thing we're going to talk about is an ammeter. And there's 2 different types we're going to talk about. The first one is a inline ammeter. This is referred to as a shunt type meter that is in most multimeters. Depending upon make and model, it may be fused at 10 amps or it may be fused at 20 amps. More often than not, people check their meter and they'll find that this fuse is blown. Before you use your meter, you want to do another pre-check on it. You're going to turn your meter to ohms again. You're going to take your red lead and put it over here in that top 10 amp port. If you get an OL reading, generally that tells you your internal fuse is blown. If you get a very low resistance, it should tell you your fuse is good. So it's a very easy, quick check, but these get blown very easily because people forget to move their leads around, turn it back to voltmeter or whatever, put it across the battery, and very quickly you'll blow that fuse. I'm just trying to make sure I keep track of our questions here and see if anything's coming up that we need to answer right now. One thing about these fuses as well is these are special fuses. If you've ever blown one and you go to buy a replacement, you'll find out they are very expensive. But these are usually a ceramic fuse. They're what's referred to as a fast-acting slow blow. What that means is, they can handle the 10 amps they're rated at, but if they exceed that, they are going to blow very quickly to protect your meter. So if you do have one of these fail because you did something silly, do not replace them with a Wrigley's wrapper. Do not replace them with a 22 shell. Do not replace them with a fuse out of your old pickup. These are special fuses. So make sure you replace them with the correct ones, and make sure you do things properly so you don't blow them in the first place. We're going to give you an example of how to protect them and where you might use this in a second. Especially with COVID, we have lots of equipment sitting around that's parked. There is lots of parasitics on today's trucks. If you look at all the different computers and the things drivers add to them, that when that truck is just sitting there, even with everything turned off, there is a lot of loads that are staying on pulling those batteries down. If you have, a bunch of trucks and so one goes dead in, 3 days versus the other ones will last 2 weeks, so what's wrong with that one truck? Why is it going down so fast? Well, we want to check and see if it's got a parasitic draw on it. If you notice in this picture, we just take a cheap inline fuse and we put little clips on it and put a 10 amp fuse in it or whatever your meter is rated at. What we're going to do is we're going to separate the ground and put this fuse in line. The reason we're doing that is we're going to make all that current go through that one point. If it blows that 10 amp fuse, that will tell you, hey, it's above 10 amps. I don't want to stick my meter in there and buy another, $15 fuse because it was above that 10 amp range. In this drawing, we're showing a very simple drawing of one battery, one positive cable, one negative cable. Not many trucks are made this simple anymore. You got multiple batteries, multiple cables that connect. You've got various grounds that come in and connect to the batteries directly. So when you do this test, make sure you get all your grounds. If you got dedicated ECU or chassis grounds, whatever, make sure you get them all. You may take and bolt them together and put that fuse holder in line. That if you even leave one single ground connected, it may make for a inaccurate reading because you didn't get all the current flowing from that battery pack. But once we put this fuse holder in and it didn't blow, we can take our meter, make sure we have it set up properly, make sure you're in the right function with your knob here, and also that your leads are in the right position. The ground, bottom right on most meters, is always going to stay in that position, but your red lead will have to move. The meter we're showing has a 10 amp port and also a 200 milliamp port. Just make sure you are on the right one. But we're going to put our meter in line in parallel to that fuse holder. And the reason we're doing that is anytime you disconnect batteries, all those devices that are pulling current are trying to stay powered up. Whenever you take that battery cable off, you'll see a spark because it's trying to keep current flowing. And whenever you reconnect that cable, a lot of times you'll see a very big spark because all those devices that are staying on usually have capacitors in them. And if they discharge from being disconnected from battery, whenever you reconnect it, all those capacitors are going to try to suck up that energy and get recharged. So we're trying to eliminate that making and breaking. So we put it together in parallel first so that we're not actually breaking that circuit again. Now, if you look at the way this meter is hooked up like this, if we had a 2.5 amp load, say a bunk light staying on, but with the way the meter's hooked up right now, even though the meter's pulling, or that light's pulling 2.5 amps, what would our meter display? Think about it for a second. You're actually kind of cheating. We gave you the answer on the screen. Is you're going to actually only see about half that current. And the reason why is half the current's going to flow through the fuse holder and half is going to go through your meter. So once you make that connection, you want to pull that fuse holder out. Now all that current has to go through your meter so you get a very accurate reading. Just like we were saying before, if you've forgotten and left one ground cable on, all that current is not going to flow through your meter, so you're not going to get an accurate reading. Now, we went through and did all this tests. We confirmed we have a 2.5 amp load. That's what's staying on. That's what's killing our battery. Are we done? No, because now we got to figure out what it is that's staying on. Is there a magic answer for finding that? Unfortunately, no. The only thing we can do at this point is start pulling fuses. That if you pull the headlight fuse and it doesn't change, you know it's not something on the headlight circuit. Pull courtesy fuse. Still doesn't do it. Pull the HVAC fuse. Suddenly it drops down to only 0.1. Well, now you've isolated it to a circuit. Now you got to find out whatever is on that circuit that's staying on, causing the parasitic draw. And that may be a clutch that's staying energized. You may have a faulty relay pulling current. Don't know. You're just going to have to isolate it down. Next type of ammeter we're going to talk about is actually on a separate piece of meter, or it may be an add-on for a multimeter, but instead of a inline or shunt type ammeter, it is a inductive or clip-on ammeter. And they all have different looks and different size jaws, different ranges, everything. But the beauty of this type of meter is you don't have to break the circuit. All you're going to do is open up the jaws, put it around that cable, and it will be able to read that magnetic flow and show you exactly how much current. And we go back a slide here, that in electricity we have what's called the right-hand rule of electricity. If you take a cable, you put your right hand on it, you put your thumb in the direction the current is flowing, and then look at the way your fingers wrap around it, that's the way it's going to generate a magnetic field. The clip-on ammeter reads that magnetic field and converts it into a numerical answer for you. So it says, hey, I see X amount of magnetic field or magnetic flux. I must have 37 amps going through it. These meters are very handy, but there's several things you have to make sure you do or don't do when you use them. Make sure you get an accurate reading. The jaws have to close completely. If they don't close all the way, you're not going to get an accurate reading. Depending upon type of meter, I'm going to back up a slide here again, is this one has a 0 button. So whenever you go to use it, hit the 0 button, make sure it is all 0. Some of the older ones used to have what we call a thumb wheel, where you had to push it in with your thumb and you turn it left and right. Those were a huge pain because you go one direction, you're at +5, you go the other direction, it jumps all the way to -7, you turn it back and it jumps up to +18 or whatever. Those were always, frustrating versus, a 0 button. But you have to 0 it out first. And the other thing too is there will be an arrow inside that jar that tells you direction of current flow. If you put it on backwards, say you're testing an alternator, you want to see how many amps is coming out of the alternator. If you put it on backwards, instead of positive 150 amps, it's going to be a negative 150 amps. Does that mean the alternator sucking 150 amps? No, it's just, hey, silly, you put me on backwards. No harm, no foul, just got to make sure you are aware of it. The other thing too is you want to make sure you have a cable you're testing away from any other circuits because again, it is picking up that magnetic field. If you had a big bundle of wires and you didn't separate the one wire away from the others, you could pick up the negative field from the other ones, or even more of another circuit that was in parallel, and you could maybe even double what the readings are. So be very careful and separate that wire from the rest of the circuits. When we talk about an ammeter, the only thing it does is read current flow, but you have to have voltage to push those amperage or amps or whatever. So the two go hand in hand, but they are totally different what they are reading. Next thing we're going to talk about is an ohmmeter. An ohmmeter is just a function on our meter that tells us how much resistance we have. This is a function people use all the time, but unfortunately, a lot of technicians don't always understand what that meter is telling them or what it displays. So I'm actually going to test y'all again. So pay attention, look at the screen we're going to show you. You get a service manual. You open it up and it says, hey, you're going to check the XYZ sensor. The XYZ sensor should have a reading of at least 6K. If you were to put your meter across that sensor and check it, is this a good or bad reading? Again, the spec called out in the service bulletin says the sensor should be at least 6K. Well, first off, you have to know how many 6K is. Anytime you get a K, it's going to tell you 1,000. So the spec says it's looking for at least a 6,000 ohm reading. If you look at what our meter is displaying right here, a lot of times people say it's 5.46. It's less than 6K. It's good. But you got to notice this big M here next to it. What does that M stand for? That M is telling you mega ohms or million. So that is not 5.46 M or 5.46 ohms. That is 5,460,000 ohms. So you got to be very careful what that meter tells you. So we got 9 more examples just kind of go through, but this is where we see a lot of technicians make mistakes, is they don't understand what that ohm meter is telling them. So next one here is we have 99.0K. How many ohms is that? Answer is 99,000. Whenever you have a big M, that tells you 10 to the 6th power, so just move your decimal over 6 places. If you have a K, that means it is 10 to the 3rd power, so you move it over 3 places. Once you get used to it, it just jumps right out at you, but again, a lot of people have not practiced with their meter enough to understand what it is telling them. Another example here, 9.58 M. So that would be 9,580,000 ohms. This trips people up a lot of times. We have a 0.990 M. So quick glance, you got the M, so you know you're on the mega scale or million scale. 0.9 says you're just under 1 million ohms. Now, if y'all ever read a tech event and you go through one of my stations, I am a stickler on this. If you don't write it all the way out, how do I know you understand what that meter said? So if you do any station that have to write something like this, make sure you write it all the way out. Make sure you convey you understand what that meter's telling you. Another one here, 9.76K. Move the decimal over 3 again. So we have 9,760 ohms. The other one, 21.71, again with a K reading. So it's 21,710. Now, I'm a stickler for making sure somebody writes it out, but I try to be fair that if you wrote down 22,000, I would accept it, because at least I know you understood what that meter was actually displaying to you. Another one that causes trip ups at times is we have a 0.546K. How many ohms is that one? And actually, it's just 546. Most meters, if it goes over 500 ohms, move it to a K scale, which you'd think, why don't you just display 546? But again, that's the way most meters are. This one, we got 14.85K. It would be 14,850. One more, 0.983K. It tells you just under 1,000. I would take 1,000 as the answer, but this is 983. And the last one here, 3.239K, tells you that'd be 3,293 ohms. Alrighty, so we went through and explained an ohmmeter. We're actually going to put it to use. One of the most common things on a truck today is a 5-pin relay. That if a truck's got one, it's got 20 of them. How do most people generally test a relay right now? To be honest, you take it out from one spot and you swap with another one. If it works, yep, I knew it was a bad relay. But trucks have gotten a lot more complicated. It ain't simply does it work or not, does it work properly. The first time most of us ever had to deal with a relay is we bought a set of fog lights or running lights or whatever for our old pickup. Inside the box was a toggle switch and a relay. Most everybody took the relay and threw it away. So what do I need that for? I got a switch. Well, the whole idea of using a relay is you can use a low power signal to activate a high current device. So that toggle switch was only ever designed to trip a relay with less than half an amp current pull to be able to activate a set of fog lights or whatever that may pull 20 amps. But the first thing we're going to do when we take a relay is we want to check it. And the first thing we would check would be the coil. So you're going to take your meter leads, go on the two outside ones, make sure you're on ohms, and we're going to see what the resistance of that coil is. On this one, we checked it, and it's 102 ohms. Is that good or bad? Well, if you don't know what the spec is, it doesn't do any good. So you have to make sure you have the spec sheets for whatever you're testing to be able to tell if it's something good or bad. This one I know was good by the brand that we use. Have the spec sheet says it should be between 100 and 105 ohms. So this is right where it's supposed to be. So that one's good. Now, if you look at this though, why all this is important is if you take your voltage and divide it by the resistance, so we're going to use 12.5 volts, we're going to divide it by the 102 ohms, says that relay should pull 0.12 amps to activate. Not a whole lot of current. And why this is important is, again, today's vehicles don't just use an old-fashioned toggle switch to activate. it has some sort of a control circuit, control module, SAM module, something that activates this relay. So if any of these things get out of the norm, it could damage them, or it may shut down because the current's too high. We're going to test another relay here. Go across the two relay coils, or the coil terminals. With this one, we get an OL. That tells you immediately that coil has a break in it. I don't know if anyone's ever taken a relay apart, but there's a little steel core, and it has hundreds of loops of very, very fine copper wire around it. Somewhere in all those loops of wire, there is a break, and no current can flow, so it can't do its job. So that one's pretty easy. We're going to grab another one here, though. Did the same check. This one comes back, it's only got 54.2 ohms resistance. So what that should tell you immediately, somewhere in all those loops of wire, you have two coils that are touching each other, so it's not going through all the loops anymore. So you have much less resistance. Run it through that same equation, though. Before we had a good relay with 102 ohms that pulled 0.12. Everything being the same now, other than the resistance, it's same 12.5 volts, but we're going to divide it by that 54.2. Look what that did to our current. It's almost double the current. So if this was a relay that was controlled by an HVAC module or SAM module, whatever, what's going to happen? One, it could damage the module. And if you go put a new module in its place, what's going to happen to the new one? Same thing, because they're pulling more current than it was ever designed to, or it may just simply shut down because it detected current was too high. But it's not a $400 module, it's a $4 relay. The other thing we can do with a relay when we test it is we can again use our ohmmeter. We're going to go across the normally closed contacts and make sure we have continuity. We can then go across our normally open contacts and make sure they are truly open. Then you may get a relay that is, because of low current or whatever, contacts may get stuck closed. One of my favorite things to do on boards too is open up a relay and bed the tang so that they can't properly close or properly open, depending upon which function we're using. Now, a couple other things you can do with a relay is, one, if you energize this relay, you could do the test backwards. Our normally closed contacts would now be open, and our normally open would now be closed. But if you really want to check a relay, is you want to test it under load. So you can put it back in service and use our voltmeter like we did before, and we can go across those different contacts and look for voltage drop. That if you get voltage drop because of relays being pitted and low current and everything, they are going to build up heat. The more heat they build up, one, it can damage the PDM, where you get heat saturation in the power distribution module. It can damage it, take tension out of terminals. Just all kinds of things that can happen because the relay, quote unquote, still works, but it's got damage that's has never been troubleshot before. So what does an ohmmeter do? It simply measures resistance. Most meters on the continuity check or on the ohmmeter check may have a diode function. This is the schematic symbol for a diode. What is a diode? Well, layman's terms, it's a one-way check valve that allows current to flow one direction but not the other. Now, one thing about diodes, there are hundreds of different types of diodes, maybe thousands of different types of diodes. They all have different qualities, different things they do and don't do. Some diodes, when they get up to a certain voltage, will allow current to flow the other direction. But for most diodes we're going to talk about, current flows one direction, but not the other. And you have a function on your meter to be able to check these. And then if you look up on the screen, you should get a little diode symbol. If you look at the knob placement, there are several different functions on that one. So you may have to use the mode button to toggle through from ohmmeter, continuity check, diode check, whatever, to make sure I'm the right one. So make sure we're on the right one. This is one of the tests that is very important, that you have a good battery in your meter, because it takes a certain amount of power to be able to forward bias that diode in order to properly check it. So if you try to check a diode with weak battery, you may condemn perfectly good diodes simply because you don't have enough power to test them. But this is actually a diode out of a great big bus alternator. Makes for a much easier picture than one off of a little circuit board. But if you hook it up this way, current should not flow this direction, so you get an OL on your meter. Simply swap your two leads around. Current does flow this direction. Most meters will give you a little chirp, and it's going to give you a numeric display. What that display is actually telling you is a voltage drop across those diodes. Another diode here, same way, it should flow this way, but we get an OL saying that that diode is bad because it is actually open. It will not allow current to flow either direction. Next one here is, it doesn't matter which way we put our leads on, we get all zeros on it, and we get a continuous beep like we were on continuity check. That tells you that diode is shorted. Years ago, whenever this would happen in an alternator, you would create a parasitic load because it would allow about 4 amps to flow inside the alternator and cause a drain on the truck's batteries. With the way diodes are made now, that hardly ever happens, but 20 years ago, we used to see that quite a bit. Again, on diode test, same function, it also has a continuity test. That if you look at the wire on the top right there, is every single strand but one is broken. If you were to do a continuity test on that wire, would it show good? Well, it depends what your definition of good is, but it is going to beep and say, hey, we have continuity. Now, that wire is pretty easy to see that, hey, it is bad. But the exact same thing can happen if you have a wire that somebody stabs with a test light and you start getting corrosion in there. The end result is still the same thing. You cannot pass any current through that wire, but it will show continuity. So continuity can be a very handy thing, but it can also get you in trouble. The other thing about continuity check is you go out and test a trailer that, hey, my lights aren't working on my golf cart trailer. You open up the connection and you put your continuity, your meter on continuity between, say, left and right turn signals. It's going to beep and show continuity. Does that mean you've got a bad harness or bad wiring on your trailer? Now, stop and think about it, that electricity is lazy. It's going to find the path of least resistance and find a way back any way it can. I've seen people start tearing harnesses out of trailers thinking they had a bad harness, but actually the actual issue was the left and right turn signals are two totally different circuits, but they will go back through the filaments of the bulbs back to ground, and they will show continuity. So be careful, make sure you understand a circuit. Anything that has a coil in it has a power and a ground. So, for example, the relay we just talked about, if you were to go from, quote unquote, the positive side of the relay to chassis ground, would it show continuity? Yes, it would, because it went through the coil of the relay back to ground. So first reaction would be, ooh, it's shorted, there's something wrong, that's, this should not be grounded. So make sure you stop and look at that circuit. I always tell people, grab a pen and pad, draw the circuit out. What's it supposed to be? Now we're going to talk about some of the functions within the meter, one of which is a hold function. This is very handy that if you're trying to, a good example is a lot of the tech events. You're trying to hold a meter across two different terminals, and you're trying to make sure you keep track of it so you can write that answer down. If you put your leads across, whether it's a battery, across a resistor, whatever, and hit that hold function, it will lock in whatever that meter was displaying. So it makes it very easy to be able to freeze those results. Other meters may have a touch hold function, and it will automatically freeze in results once it sees a reading. That can be very handy if you're doing like checking if you have brake light power. I don't know any of us that are fast enough to hit the brakes and run to the back of the vehicle and see if the brakes came on. So the hold feature can be very handy to give you that extra set of eyes or a third hand, whatever you're trying to do into these checks. Just whenever you use it, make sure you turn it back off. Min-max functions. These are on most all meters too. Let's say you're checking a voltage, whether it's across the lift gate or you're across the starter. You want to capture the min-max. When we say min-max, it is going to be the highest reading you saw and also the lowest reading you saw. You simply hit the min-max function and it will lock those in for you. Next one we're going to talk about is a relative function. This works a lot like the relative or the min-max function, but can be a lot handier. The relative function can act as a zero. That if you want to be a little bit more accurate, and your meter may say 0.1 volts before you even start, you can hit the relative and it will take it to 0. But where it's very handy is if you're trying to see a difference in voltage. Whether it's a starter under load, pump motor under load, blower motor, whatever, that you can put it across whatever the device is, hit relative, that will take it to 0, and then it's going to display anything that changes. So, for example, you're checking a taillight circuit. You can put it across it, and zero it out at 0 volts, and then see that's if you added another light to it, what did that do to your voltage supply? Blower motor, see what it does under different settings. You start off with it at 0 with it on low, you crank it up, and whatever that number displays is telling you how much drop or change there is in that circuit. So it can be very handy. Checking, it's not a great way to do a voltage drop check, but it can at least quickly tell you a difference between two different points. So very handy to remember to use that one and take advantage of it. Pulse width modulation, it's another function within a lot of meters. What's generally looked at or displayed is a percentage. And what is pulse width modulation? It is the ability to control things by turning something off and on. Most vehicles don't have dedicated running lights or daylight running lamps. What they do is if you turn on daylight running lights or they're automatic, it uses your same headlights, but instead of giving it a full 12 volts or 14 volts, engine running, it will control how much it's on versus how much it's off, and it will regulate to give you a lower voltage. So yes, it's headlights, but they're only on at 50% brightness, and they do that by turning off and on 50% of the time. So less current, a lower voltage, less output. Same thing with blower motors. It used to be we had a blower motor resistor pack, and you had 3 distinct speeds because it went through 3 different resistors. With pulse width modulation, you can have basically infinite blower motor control because it'll be anywhere from 1% on to 100% on. And that's what your pulse width modulation or that percentage feature will give you, is a readout of, again, 0 to 100 of how much that signal is on versus off. It's also how they control fuel injection. The more it's on, the more fuel is going to send into the engine. So simply the percentage function on your meter and displays how much current is, or how much it is on versus off. Hertz or frequency, again, usually the same function. It's going to give you it'll just give you an HZ, or may actually say FREQ for frequency. Where we're going to use this most of the time on today's trucks is going to be inverters. Make sure the inverter's putting out the proper frequency. Like anything else we talked about before, you get what you pay for. If you buy a cheap inverter, it may not have very good frequency control. Yes, it is 110 power and stuff does work. Does it work right? No. So it is an easy way to check that. So lots of other functions are made into your meter. You just got to be familiar with them and use them. One of the biggest things I'll tell you on all these things, the only way you're going to get good at using a multimeter is to use it. How many people still have a test light? What does a test light tell you? And I'm not talking about any of the high dollar specialty ones, but a typical generic test light, all it tells you is you have something or nothing. Whereas a meter can tell you exactly the voltage. When you look at a lot of devices now anymore, and I do a lot of tech calls for our products and other products out there, that's, you ask somebody, well, what's the voltage? And he replies, good. What's that immediately tell you? Person does not have a meter. They're probably using a test light, or they, touch the wire to ground and, say it's good. Most devices are, looking for a certain voltage in order to, turn on or turn off or whatever. So if you don't have a multimeter and don't know how to use it, you can't troubleshoot it. One thing for reference, it's in our reference library. If you want, you can email me. I'll be more than happy to send this to you, or I can send you some actual physical ones. This is a little meter cheat sheet card. Not only does it give you all the breakdown of the K's, the M's for the ohmmeter function, but it also gives you all your different formulas for doing all your calculations on these things. How to figure watts, how to figure amps. So it can be very handy. We're going to open it up to questions. One thing is, please don't drop off immediately, because we do have some follow-up questions after this. And I'm going to open up the Q&A section here and see if we have anything live. If I don't get to you, because we are running out of time quickly, feel free to send me an email or type it in, and I will follow up afterwards directly. So I'm going to see if I can pull this up and take a look. Had one person ask, can we share the slides? This is a huge file because of all the pictures, and I can't email it, but everybody tomorrow that registered for this will get a email with a link to see the recorded version. You can watch it over and over again. Also, too, in the reference library is the link for the test you can take. There's, I believe, 27 questions. If you get at least 22 of them correct, comes out to 80%, and it will generate a training certificate for you. And you can take that test over and over again if there's something you missed, didn't understand. And also, too, my contact information is there. Feel free to text me, email me, whatever. We'd be happy to help you any way we can. These are all, again, saved on our website. There are also snippets of all these that are on YouTube. You can go back and watch it anytime. But again, the recorded link will be sent to everybody tomorrow. Someone asked, what meters do I prefer? We try to stay away from, calling out anything brand specific on these, because we're not trying to really promote, anybody. The biggest things I'm going to tell you is stay with the name brand, do some research, find out who has calibration programs. That is one of the biggest things for me is, can I send this thing in and get it calibrated, once a year, which I would totally recommend you do that. You're not going to get a good meter at the discount tool store. If you don't spend a couple $100, you're probably not going to get a meter that's going to do everything you need to. But at the same time, don't get fooled thinking you have to buy the coolest, most extravagant meter in the shop because you want to be the coolest kid. Buy a meter that's going to do all the things you need to do, but don't buy one that's got 87 different functions that you're never going to touch in your job. So I hope that answers your question good enough on recommendations. But yeah, buy a good one, but don't get crazy. Also had some inquiries about other repeats of this. Again, it will be, it is recorded, and an invite will be sent to everybody. You can log in tomorrow. Feel free to share that with anybody else. I do try to track that. So if anybody wants to know, who at their company attended it. All you got to do is send me an email. That we do try to work with trainers, make sure people get credit for attending these. So anything we can do to support you on that as well. And I think that's it for questions. If anybody's got anything else, feel free to send them to me. Anything else I will send back out later. But thanks again. I'm going to drop out here, and again, please answer the survey questions afterwards.